OpenStax College Algebra. You can download the OpenStax College Algebra textbook at openstax.org. In this video, we're going to cover polynomials, chapter 1.4. The etymology, or the history of the word polynomial, well, it joins two diverse roots, the Greek poly, meaning many, and the Latin nomen, meaning name. René Descartes, who was a French philosopher born in 1596 and died in 1650, is one of the people who introduced the idea of a graph of polynomial equations. So let's define polynomials. A polynomial with only one term, like 5x to the power 4, is called a monomial. A polynomial containing two terms, such as 2x minus 9, is a binomial bi for 2. A polynomial with three terms, such as negative 3x squared plus 8x minus 7, is called a trinomial. Now we can find the degree of a polynomial by identifying the highest power of the variable that occurs in the polynomial. The term with the highest degree is called the leading term. So we can see that here. In this case, it's a sub n x to the power n. So the leading term is a sub n, that's just a constant, x to the power n. So the leading coefficient is a sub n, and the degree is n. So a polynomial is an expression that can be written in this form. So the leading term is a sub n, x to the power n, and we just keep adding. We go down to a sub 2 x squared plus a sub 1 x plus a sub 0. That's a polynomial. Each of these constants, a sub I, is called a coefficient. And each term, if we have a sub I x to the power I, is a term of the polynomial. And we've already seen the highest power of the variable, the highest power on x, is the degree of the polynomial, and the leading term here is the term with the highest power. And of course the coefficient, or the constant next to the highest power, is the leading coefficient. In example 1, we want to identify the degree, the leading coefficient of a polynomial. So in part A, we have 3 plus 2x squared minus 4x cubed. So this is the term with the highest exponent. So the degree is going to be 3 because that's the highest exponent. And the leading term, so I'll write leading term is minus 4x cubed. And the leading coefficient is negative 4. In part B, we have 5t to the power 5 minus 2t cubed plus 7t. And again, this first term now is the term with the highest exponent. So the degree in this case is 5, because the degree is the highest exponent. The leading term, well, that's the whole thing, so that's 5t to the power 5, and the leading coefficient is 5. Part C, 6p minus p cubed minus 2. So the degree in this case is the degree of the highest exponent. So that is 3. The leading term is minus p cubed, and the leading coefficient is negative 1, because this is like negative 1 times p cubed, isn't it? Example 2 requires us to add polynomials, and that means we have to combine like terms. So I'm going to rewrite this and put all the like terms together. So 4x cubed is the leading term, and there's no other cubed terms anywhere, plus, and I'm going to group together the x squared terms. So I have 12x squared plus 8x squared. Now I'm going to group together the x terms. So I have plus 9x minus 5x. And finally, just the numbers. So I have minus 21 and plus 20. Now, this would very often be performed as a mental step, but when we're first talking about things, I think it's good for me to write it out. Be sure to connect your expressions with equal signs, so don't just leave it blank. That's not good mathematical notation. So here I have 4x cubed plus 12 and 8 is 20, x squared. 9x minus 5x is plus 4x, and minus 21 plus 20 is negative 1. So I've written the final answer in what we would call the standard form. And standard form means the leading coefficient or the leading term first, then the next lowest, then the next lowest, etc., down to just the number. Example 3, we are subtracting polynomials. This is the same as adding the opposite of the second polynomial to the first. First, I'm going to start with the leading term, so that looks like it's 7x to the power 4, and there's no subtraction there. The next highest term is 5x cubed, so that's going to be minus 5x cubed. Then we have negative x squared, negative, so that's going to be a plus 2x squared. And then we have 6x subtract 3x, and 1 subtract 2. And that will leave us with 7x to the power 4 minus 5x squared plus x squared plus 3x minus 1 in standard form. When we multiply polynomials, we have to use the distributive property. So for example, if I want to multiply 2 times the quantity x plus 7, I have to multiply 2 times x plus 2 times 7. Of course, that'll give me 2x plus 14. Example 4, we want to find the product of the quantity 2x plus 1 multiplied by 3x squared minus x plus 4. So we'll have to use the distributive property, and that means we have 2x times the quantity 3x squared minus x plus 4 plus 1 times the quantity 3x squared minus x plus 4. So that gives us 6x cubed minus 2x squared plus 8x plus 3x squared minus x plus 4. And now we need to combine like terms. So the first step was the distributive property, then we multiplied it out. Now we combine like terms. So I have 6x cubed. Now I need all the x terms together. Minus 2x squared plus 3x squared is just plus x squared. Plus 8x minus x is plus 7x, and then plus 4. And there's my answer in standard form. Now I'll talk about a shortcut called FOIL, and this is just a shortcut to apply the distributive property, and it's called FOIL because FOIL stands for multiply the first terms together and then the outer terms together, then the inner terms together, and then the last terms together. FOIL. So what does that mean? Well, if I want to multiply the first terms together, that gives me AX multiplied by CX, the first terms together. Next, I would do the outer terms. So the outer terms are AX multiplied by D. So that's AX multiplied by D. Okay, so here I have first terms multiplied together, then I have the outer terms multiplied together. Next, I need the inner terms multiplied together. So that is plus B times CX, so that's the inner terms multiplied together. And finally, I would have the last terms multiplied together, and that is plus b times d, or the last terms. Example 5 asks us to use the FOIL method to multiply the binomials. First quantity 2x minus 10, second quantity 3x plus 3. So I'm going to do the first terms first, and I'm going to write this down. This would normally be a mental step, but here's our first term, and then I'm going to do the outer terms, so that's 2x times 3. Now, usually this would be a mental step. Then the inner term, so that's negative 10 times 3x, and finally the last step, so that's negative 10 multiplied by 3. So remember, I'm writing this down, but normally this would be a mental step. And then I'm going to have 6x squared plus 6x minus 30x minus 30. And then what I need to do is write this in simplified form or standard form. So 6x squared, I combine the like terms, so plus 6 minus 30 is minus 24x minus 30. In the case of a perfect square binomial, the result of the first term squared is added to double the product of both terms in the last term squared. So actually, the word square comes from the picture I've drawn here. So the length of this side is x plus a, and the length of this side is x plus a. So we have x plus a squared, and that's a perfect square. And that's actually going to equal, if I look at all the different parts of the square, this inside part right here is x squared. Then I have 2 times 2 rectangles, the length ax, plus a perfect square, a squared. And this has a geometric as well as an algebraic expression. In example 6, we're asked to expand the perfect square, and that's 3x minus 8 all squared. And I'm going to work this problem out in 2 different ways. I'm going to first of all FOIL. So I have 3x minus 8, and I'm going to have to multiply that by 3x minus 8, and that's going to give me 9x squared minus 3 8s are 24x, minus 3 8s again as 24x, plus 64. And of course, that's going to be 9x squared minus 48x plus 64. So that's the first way. The second way I'm going to work this problem is to use the perfect square trinomial idea. So I know that I have x squared, and of course in this case, x is replaced by 3x, isn't it? That's the first term. So I have 3x squared, or 9x squared. And then I have 2 times the product of 2 times a times x. So 2ax, and that's going to give me 2 times negative 24x. And then I have plus a squared, so that's going to be plus 64. So it's just a little bit of a shortcut here. Ax, of course, in this case is going to be 3x times 8, or negative 24, isn't it, x? And of course, a here is just minus 8, and that squared is 64. So I'm going to get 9x squared minus 48x plus 64. Well, what about the difference of 2 squares? And in this case, we have x plus 1, and then it multiplies by x minus 1. And what happens there when we FOIL it, we have the first term, x squared, minus the outer term, or plus the outer term rather, it's minus x, plus the inner term, plus x, minus 1, because positive 1 times negative 1 is 1. And you notice what happens here is these middle terms drop out, And we are left with x squared minus 1, and that always happens. It's always true that the middle term drops out. So just like with perfect squares. Now this is not a perfect square because one side is x plus 1 and one side is x minus 1. But if I have x plus 5 multiplied by x minus 5, we know the middle term will drop out. So it'll be x squared subtract 25. And it's always a negative here. There's always a negative when we do these products. In example 7, we're going to multiply binomials resulting in a difference of squares. So here I have 9x plus 4 multiplied by 9x minus 4. And again, I'll do this in two ways. The first way is the long way. I'm going to FOIL it. So I have 81x squared. That's the first terms multiplied together. Then the outer terms. So I have minus 4 times 9 is 36x. Then the inner term, so that's going to be plus 4 times 9 or plus 36x. And finally the last terms, and that's going to be minus 16. And it's always the case here that in a difference of squares, the middle terms cancel out. So I will have 81x squared minus 16. The second way of doing this is to apply the rule of the difference of squares. So 9x plus 4 multiplied by 9x minus 4. I know that I have the first term squared, so that's 9x squared or 81x squared. Subtract the last term squared, which is 4 squared or 16. So obviously using this rule is a lot quicker. The final example from this section is multiplying polynomials containing several variables. So I have the quantity x plus 4, and I'm going to multiply the quantity 3x minus 2y plus 5. So I just have to repeatedly apply the distributive property. So that's going to equal x multiplied by 3x minus 2y plus 5. And then I'm going to have plus 4, and that's going to multiply that quantity 3x minus 2y plus 5. And this gives me 3x squared minus 2xy plus 5x plus 12x minus 8y plus 20. And the final step is always to combine like terms. So I have 3x squared minus 2xy plus 17x minus 8y plus 20.